In this lesson, we're going to be proving the Pythagorean identity and using it to calculate some trig ratios. Looking at our big picture, we see it's in Unit 10, it's Lesson 8 on Day 10, and it's the last lesson in this unit. And then when we look at the scope and sequence, just like all the others, it tells us how many days we have for this lesson, what course of study objective it covers, number 36, teacher notes, prerequisites, materials needed, and presentation strategies. So we have this right triangle, and we know the Pythagorean theorem is a squared plus b squared equals c squared. Now, we're going to express a and b using sine and cosine. So we're going to have sine of x equals, here's x, so opposite over hypotenuse would be a over c. Cosine of x is b over c. And then we're going to solve these for a and b. So that's going to be c sine x equals a and c cosine x equals b. Now, if we take the Pythagorean theorem and we substitute the c sine of x for a, that's going to be c sine of x squared, and the c cosine, let me rewrite that, c cosine x squared for b, and then that equals c squared. Okay, so let's square this. So that's going to be c squared sine squared x plus c squared cosine squared x equals c squared. Now all three of these have a c squared in it, so let's divide by c squared. And we have sine squared x plus cosine squared x equals 1. And that is our Pythagorean identity. Now, let's look at finding that a different way. Very simply, in the unit circle, we know the angle at the origin, we're going to call it theta. We know the hypotenuse is 1, and we know that this is our cosine value, the x, and this is our sine value, the y. So we can substitute in, if we have a squared plus b squared equals c squared. In this case, one of these sides is a, so cosine squared, b, sine squared, and c is 1, so that's 1 squared. So we have cosine squared theta plus sine squared theta equals 1. So that is our Pythagorean identity. And it doesn't matter whether you write sine squared theta plus cosine squared theta, either order is fine. So now let's learn a couple of problems. So we're going to find sine of x. We're given cosine of x is 3/5, and we want x to be between negative pi over 2 and 0. So let's look at sine squared x plus cosine squared x equals 1. Well, I don't know what sine of x is, but I do know cosine is 3/5. So then I have sine squared x plus 9 over 25. And I could write this as 1, but I know I'm going to want to move this 9 over 25, so I'm going to write it as 25 over 25, so I have a common denominator. So then I have sine squared x equals 16 over 25. So now I'm going to square root both sides. So that gives me sine of x equals plus or minus 4/5. Well, I've got to figure out whether sine x is positive 4/5 or negative 4/5. So that's where this comes in. So let's look on an xy axis. Here's 0. Here's negative pi over 2. And we want sine in the fourth quadrant. Well, we know in the fourth quadrant, x is positive and y is negative. And if we think about our unit circle, x is cosine, y is sine. So sine is negative in quadrant 4. So that means sine of x is negative 4/5 based on this information. All right, let's look at another problem. It's telling us to rewrite the expression cosine theta times sine squared theta minus cosine theta in terms of 1 trig ratio. Okay, so let's start with cosine theta sine squared theta minus cosine theta. Now, when I look at this, both sides of this have a cosine theta in common. So I can factor that out. And then that leaves me sine squared theta minus 1. Well, anytime I see sine squared in a 1, cosine squared in a 1, then I always think of my Pythagorean identity. And I think, is there a way I can rewrite this so that it looks like this, that part of it looks like this? So I want this to be a minus 1 with the sine squared, so that means I need to move this to this side, and then I'm going to move the cosine squared theta to this side. Okay, so let's do that. So we have sine squared theta minus 1 equals, if I move this over here, it's going to be minus cosine squared theta. Now, this looks exactly like that. So I can substitute negative cosine squared theta. So I have cosine theta, and I have negative cosine squared theta. So just multiply those together, and I've got negative cosine cubed theta. And I use my Pythagorean identity to get that. Now, you all are going to finish this lesson, and someone will be putting 1B and 2C on the Google Slides. Now, that finishes the 4 lessons we've been working on, and everybody has one problem assigned to them to put on the Google Sheets from those 4 lessons. And you will present those in the Zoom meeting this afternoon.